Welcome everyone. In this video I'm going to talk about my extended air quality station or air quality / weather station. So I put everything together on this breadboard, but later on I will show you another drawing of the circuit so you can see how the connections are made up. So now let's talk about the parts which are in this system. So first of all, we have the Arduino Nano here, and then we also have a 128 times 32 OLED display. You can display 4 lines on this. It's very good. It's very convenient because you can show a lot of data. This big metallic box is a dust sensor, so it measures the amount of dust which is inside the chamber of this enclosure. And then if we go to the other side, this is a CCS811 VOC, volatile organic compound sensor. I will just use this as a carbon dioxide sensor because this can convert the data to a carbon dioxide equivalent data. It can also measure the temperature, but I don't really trust the value which comes from it. And then this guy, BME280, is a very good circuit because you can measure temperature, humidity, pressure with this single device. And also you can convert the pressure to altitude, so you can measure a lot of nice things. So as you can see, this is a very compact circuit. You can put it on only half of this breadboard. It's very convenient, and you can put this in a small box and put it outside of your apartment or home, or wherever you want to put it. You can put it in your room and monitor the air quality inside your room. So for example, you can measure the dust, how dusty is the air in your room, and so on and so on. So it's up to you how you use it. I will just show you how to start up this thing, how to connect the different parts together, and then how to capture the data from it. So now I connect the Arduino to a power source, which is a mobile charger as usual, and we see what is being displayed on the screen. So this will take some time while the screen starts up, but we can already see. So here we can see the formatted data. I don't know how much it is visible on the monitor, but I can see that the screen is like flickering, so it's not so useful to show anything on it, but trust me, it works. And later on I will show you on the serial terminal and on my own software that the actual data is coming out from this thing, and it measures everything properly. But what I did is the first line is for the temperature and the humidity, and then the second line is for the pressure and the altitude in meters, and then the third line is the CO2, and the fourth line is the amount of dust in microgram per cubic meters. And all these things which is displayed here, I will explain to you how it is displayed and what did I do during writing the code, and so on and so on. But you can see that this is a very nice compact circuit, and therefore it can be put in a small box. But make sure that if you put this in an enclosure, there should be air moving around the sensors, because otherwise it will not measure the proper things. So all these sensors, these 3 things, should be exposed to air. Maybe you might want to use some very, very small fan to circulate the air around the different sensors. But I think that the convection in your room should be more than sufficient to measure changes in the dust or to measure changes in the temperature and humidity. So this is all. You can see it's not a difficult circuit. And now I will show you how everything is connected together, and then I show you the code and some demonstration of this thing in action. So let's jump to that part. So let's first of all go through all the parts and the connections. So of course the main part of this circuit is the Arduino Nano, and then all the other things are connected to this. So the new part in this circuit is this BME280 sensor, which is a temperature, humidity and pressure sensor. So it's very nice because you can measure all these three things integrated into one circuit board. And it works with I2C, so you basically need two wires for the communication, which is the SDA and the SCL, so data and clock. And of course you need some power supply. And the huge advantage of this I2C is that you can connect devices parallel to these connections. So you just use the A4 for the data and the A5 for the clock from the Arduino, and then you just connect these two things via a resistor to the high, which in this case is 3.3 volts, and then all these connections can be connected parallel. So for instance, I have this pressure sensor, and then I also have the VOC sensor and the OLED display connected to the same A4 and A5 pins, and they can do the job parallel, as you saw it. So again, we have A4 and A5 between the SDA and SCL pins of each I2C component, so this BME 280, and then we have this CCS 811, and then you can also see that SCL and SDA go to A5 and A4 respectively, and then I continue this SCL to the same SCL of the OLED, and the same SDA goes to here. And you can see that the SDA is green here, so you can follow it, and the SCL is blue here, so you can follow it again. And we have the two resistors connected to the VCC, which is in this case it's the 3.3 connection. So we have the three I2C things connected. You can see that nothing extra is done here, so the ground is always the common ground, and the VCC is always the 3.3 volts. So for the I2C devices, for these three, let's say, digital devices, I only use the 3.3 volt and nothing else. And then here we have this dust sensor here, and as you can see that the pins are a bit messed up because they are not the same distance as the distance between the connections in the breadboard, but I think you can follow it. So if we start from this pin, you can see that this goes to the 5 volt through a resistor, and then also a 5 volt directly goes to the pin 6. So the purpose of these two wires is the following. So we have this pin 6, which is simply the VCC, and then we have the pin number 1, which is the voltage for the LED. So that's why we need this resistor here to limit the current, and this resistor is always supplied with this dust sensor, and also this electrolytic capacitor is also provided, so there should be no problems with this. And then we have two ground connections. Of course, the pin number 2 is the ground connection for the LED, which is inside this sensor, and then the pin number 4 is also a ground, and that is for the sensor, I guess. And you can see that two other wires go to the Arduino. So A3 of the Arduino is connected to pin number 5, and this is basically the output voltage generated by the infrared sensor inside this circuit. So this will basically generate a voltage which is proportional to the amount of dust registered by the sensor. And then we have the pin 3, which again goes to the D2, which is used as a digital switch. So basically this pin, which is the pin number 3, is turning the LED on and off inside the sensor. So in my previous video I explained how this works, but basically you have an LED diode which provides light, and you have a sort of a sensor which can be a photoresistor or photodiode or something like this, and then the light gets scattered on the dust, and the backscattered light is detected by this sensor, let's call it sensor, which can be a photoresistor or photodiode or phototransistor, and then the diode or the sensor generates an output voltage which is proportional to the reflected light, and of course the reflected light, or the amount of the reflected light, is proportional to the amount of dust inside the sensor. So the more dust you have in the air, which is inside this chamber, the higher output voltage you will generate, which is read by the A3 leg or pin of this Arduino. So more dust, more output voltage. This is how it works, essentially. And then here you can just see how all the other things are connected and how the capacitor is connected, and so on and so on. But basically what we need to know is that here we use the 5-volt rail. So you can see that this bottom rail with the red marking here is the plus 5 volt, and then the top rail here is the GND, so the ground, and then that's how I connected everything. But this is basically the whole circuit. I hope you can copy this from the picture, and then you can plug everything in your breadboard. And now let's jump to the code. So this is the code here. I haven't done anything fancy. I just added a few lines to my previous code, and I added some new ideas so I can use the OLED display in a better way, and I can organize the data in a better way. So we just include the libraries, and in one of my previous video where I was talking about radio transmitter and receiver, I was using this kind of library for the OLED display, because by default most of the people use the graphical library for this kind of displays, which is not a good idea because it takes a lot of resources. It uses a lot of resources. So at the end you will not be able to use a lot of variables, a lot of RAM and memory in your Arduino Nano if you are using that kind of library. So instead of that, I'm using the ASCII-based library, which uses significantly less resources, and you can store a lot of variables, you can do a lot of things, and you can have a long code. So here I just do that, and then we create the object, which is called display in this case, and that's all. And I included this wire.h, and then for the VOC sensor, which is used for the CO2, we have this library from Adafruit, and then we have another library for the pressure, humidity, temperature sensor, And then we just create one object here and another object here. So we will refer to the devices by CCS and BME. We don't need this, but you need this when you use this BME 280 sensor in SPI, but I'm using I2C, so I don't use the SPI, like obviously. You can define the sea level pressure, so you can calculate your altitude based on your pressure value, but you have to make sure that the sea level pressure is defined. And then I have some variables here. So this will be the amount of CO2, and then this is the temperature read by the CCS 811 sensor. And then we have the dust sensor. So if you remember from the previous image, we have A3, so that's the analog digital converters pin. So we measure the voltage on this, and this is the LED, which is D2, and this is the LED, the infrared LED inside the dust sensor. So we will switch it through the pin number 2. This is the raw output of the AD converter, and then the dust density is the converted output. I did this because I send the raw data through the serial port, but I print the processed data on the OLED display. So this is why I have two variables for the same thing, essentially. And we have the BME 280 sensor, so I just define these 4 variables, which I will use. Delay time is required by one of the libraries, so we have to do that. And then string output data. So I basically attach together a lot of data and put them into a single string, which is this output data, and then I send this output data through the terminal to the computer. And then we go to the setup here. So of course we start the serial and then we print some message. I have a processing software which I will show you later, and I use this asterisk or star to tell the software that it should neglect these kind of lines. So wherever I have a star, these won't be considered by the software. And then we just check if the devices are available. So this is the CCS 811. We can set an offset temperature. This is very important because actually I have noticed that the CCS measures significantly different temperature than the BME sensor. So we have to define the offset properly. And then we also check if the BME is available, and here we use this delay time as well. And then we do another, let's say, check and startup sequence for the OLED display. And then if you remember, we need a pin which controls the dust sensor. So this is basically the dust LED pin, and we set it up as an output. And basically this is all. So then before going into the main loop, I just go through these other functions, so you will understand the main loop in a better way. So we measure the dust, and if you remember from my previous video where I already did this, we have to turn on the LED. We have to wait for 280 microseconds, so the voltage will reach the peak, and then we read that peak, and we just turn off the LED, and that's all. And we can like do this as many times we want, but we just do it once. And then we measure the VOC, which is, in this case, it's the CO2. So we check if the device is available, and then we just try to read the data. So we get the CO2 values, and we get the temperature value, and that's all. So now we already have the amount of dust, and we have the CO2, and we have the temperature from this sensor, so from the CCS 811. And then let me go here. So we measure the data from the BME 280. So this is very simple. So we just fill up the 4 different variables by the temperature, humidity, pressure, and altitude. That's all. And first of all, let's talk about the serial port. So we have this output data, which is this lot of string values put together. So the temperature from one sensor, from the other sensor, the humidity, pressure, and then this is the raw data for the dust, and this is the CO2. So this is all the data that I'm sending to the computer. I just put here the formatting. So each variable is divided by a tab here. So there is a tab. And I put this comment here. So if you want the dust density directly sent to the computer and not the raw data, then you just apply this function, and that's all. And what we do with the OLED display, this is very simple. So actually I should notice that I'm using the 128x32 OLED. So it has 4 lines, and then we just clear the display just once. Just do it once when you refresh. So you basically clear the display and then put the cursor in the 0, 0 position, and then you fill up the first line. And here I chose to fill it up with the temperature and the humidity, and then we don't clean the screen, but we jump to the second line. So this is the line number, and this is basically the column number, the first character or first argument of this function. And then in the second line we have pressure and altitude. It's quite simple. In the third line there is only one value printed, which is the CO2 amount, and in the fourth line I display the amount of dust. And as you can see, we convert the raw data into micrograms per cubic meters. So that's all. And now we can go to the loop. So what happens in the loop, we do this. So we measure everything by some delay between the different measurements. And then we refresh the OLED display, and then we wait for 1 second. And if we just use the device as it is plugged in into a power source, then we skip over this part. But if you use it with your computer, then you are able to send a command which can start up your device, and then if you send a capital S, then it will again measure everything and print the data to the OLED. But also it will print the formatted data on the serial terminal, and it does this printing as long as you don't send capital N character. But if you are not using it in, let's call it serial mode, so you just skip over this, then the data is only being printed on the OLED display. So let me just show this to you. So here's the terminal, and we got the first message, which is dust and VOC sensor. So now I can see that the OLED is constantly showing the data, and it is updated every 2 seconds roughly. But I can send a capital S, and then I can see what happens. So what should happen is that I receive a single line which has several values in it, and each line should come roughly in every 2 or 2.5 seconds. So capital S, and let's just send it. So the first data came, and the second. And as the sensor is just in front of me, so for example, the last data is the CO2, then that is constantly changing as I'm talking and breathing. So if I blow on this sensor, then this should have a significant jump. So let's check the last value of this sensor, and now I should blow on it. As you can see, it increased by a lot. And now it goes back to normal as the CO2 is getting mixed with the air. So you can see that you can send this formatted data to the computer, and then you can analyze it. And I made a software for that, so let's check that as well. So I quit this now and start the new software. So this is the visualization software. So as you can see, I put the pressure and humidity in the first chart. At the second chart, we'll have the dust density and the CO2 amount. And the last chart in the top, or in the bottom, sorry, we'll have the temperature data from the two different sensors. In the left side of this panel, we can choose the different data that we would like to visualize. I also made everything into averaged values as well, so we can not only print the single value, which is received directly from the device, but by the time we calculate the average of the value, and that's also displayed. So we can see if there is something unusual happening, there is a spike or a drop in some of the values. So let's just select the pressure, humidity, dust density, CO2, and then the temperature from the two different sensors, and let's just connect to the device. And now all I have to do is I just have to press start. And now you can see that the data is being displayed. So at every 2.5 seconds, we have the data displayed on this chart, and we can do this as long as we want. So basically this is all. This is good because it's easier to visualize everything, and it is easier to see what is happening, and so on and so on. And as you can see, I still have to adjust the size of the charts because the label down here disappeared as the chart, as the data on the chart appeared, and also we lost the secondary y-axis labels, but it doesn't matter at this moment because I'm still working on this software, and this can be easily adjusted, so it's not a problem. But as you can see, we can receive the data, and we can visualize the data. We can make this even faster. It doesn't really limited. It's only limited by the functions in the different chips. So some of these chips or circuits, for example the dust sensor, they need a certain amount of time to measure the value. So that's one of the limited factor, but for us we don't really need that quick readings. Just for fun, I will blow on the CO2 sensor, which is here, the black dots, and we will see if it moves up significantly. Yes, so as you can see, the scale jumped to 8,000 now. Previously, if you remember, I also did something similar. It was almost 8,000. So as I blew on the chip, it went up quite high, and also you can see that the blue dots, which is the humidity, went up somewhat, and that's of course because you exhale somewhat humid air. So from your lungs you always have some water exhaled, so that's why you can see a small spike in the humidity too. But you can see that this thing goes back and everything seems to be normal. So this was the video. I hope you learned something, and I hope that this was useful to you. And I uploaded the source code of the Arduino as usual to Pastebin, so please check that. Don't forget to subscribe, and see you in the next video.